Okay, it's a video on A2. So A2 is all stuff about quadratics, kind of a recap from grade 10 math. So if you take a quadratic function like this one, you should be able to find the roots, the vertex, the y-intercept, any key features that you might need in order to graph it or describe certain features about the graph. So if we wanted to quickly find the roots, we got a couple options. Factoring is our best option, so you want to get good at that. And then the quadratic formula, also a good option. But if you can factor it, you should always do that first. Okay, so in this case, it looks like we can factor it. It's a complex trinomial. So I'm looking for two numbers that multiplies to negative 12 and adds to positive 1. So I think my numbers are negative 3 and positive 4. So I'm just going to replace my middle term with those terms, negative 3x, positive 4x minus 6. And then I'm just going to common factor each half. So that's going to be 2x minus 3. And I can factor out a 2 from these ones, so 2x minus 3. And then since my brackets are the same, I can factor those out, leaving x plus 2. Okay, so once I factor my equation, it's easy to find the roots because I set my equation equal to 0. So therefore, each of the brackets must be equal to 0. So 2x minus 3 equals 0, or x plus 2 equals 0, and then I just isolate x. So in this case, x will equal 3 over 2, and this one, x will equal negative 2. So I know I have a root at 3 over 2 and negative 2. So these are my two roots, or my two x-intercepts. So if I was going to graph this function, I know I have one x-intercept at 1.5 and one at negative 2. I also know my parabola is going to open up like that because a is positive. And I can easily find my y-intercept. It's just my constant there. So if I were to set my x values equal to 0, so I know I'm going to have an x-intercept at negative 6, or sorry, a y-intercept. So if I want to find my vertex, I've got a couple options. So to find my vertex, I can partial factor. So we learned that in class. I can complete the square. Or I could take the roots, find the middle, and get my y-intercept from there. So since I've already found the roots here, I think I'm going to use the roots to help me find my vertex. But you can choose any of those three options. So if I want to use the roots, I know my vertex has to be directly in between them. Now they're not the nicest numbers, so if I wanted to find directly in between, I could just add them together. So negative 2 plus 3 over 2 divided by 2, which if you're converting to decimals, negative 2 plus 1.5 is going to be negative 0.5 divided by 2 will be negative 0.25. Or if you're keeping them as fractions, then that would be negative 4 over 2 plus 3 over 2 over 2, which would equal negative 1/2 divided by 2, which is the same thing as saying negative 1/2 times 1/2. Sorry, I forgot the negative, which is negative 1 over 4. Okay, so that just finds me the x value of my vertex. The x value is negative 1/4. So I still need to find the y value of my vertex. So in order to find y, I would use my equation, 2x squared plus x minus 6, and I would just sub in either the decimal or the fraction, whatever you want to use. I'm going to use the fraction, negative 1/4 squared plus negative 1/4 minus 6 And then I'm just finding what my y-intercept is. So negative 1 over 4 squared would be 1 over 16. I'll just change that to minus a quarter minus 6. And 2 times 1 over 16 would just be 2 over 16, which is the same thing as 1 over 8. Just going to switch it to that. And then I just want to make my denominators the same. So I'll do 1 over 8 minus 2 over 8 minus 48 over 8. Okay, so that's going to give me negative 49 over 8. Not a super awesome number. So 49 divided by 8. So if I were to sub the decimal in instead, should have got 6.125. Okay, so sorry, my answer is negative 6.125 or negative 49 over 8. So if I want to add that to the graph, I know my vertex is at negative 0.25 and negative 6 point something. So right there. So when I'm graphing it, my vertex, my y-intercept, and my 2 roots. And if you don't like that method where you find the roots and then you find the value in between and then you sub that in, that's just one method. So you should also be familiar with completing the square and partial factoring, which I believe I made other videos on if you need a refresher. Okay, you should also know how to determine equations of parabolas. So I've given you the roots, 3 and negative 2, and it's passing through a point. So if we're going to use our equation in factored form, since we know the root, that's probably in factored form. Yeah. Well, we do know our roots. So when we enter them in like this. And then we're going to use our point as our x, y values to help us find a. So we're subbing in negative 6 for y, 1 for x. So negative 6 equals a times negative 6 equals negative 4a. I'm going to divide both sides by negative 4. So a is equal to 6 over 4, which if I divide those both by 2, that's 3 over 2. So once I find my a value, I can write my equation. 3 over 2, x minus 3, x plus 2. And I can leave it in factored form like this. That's fine. Factored form is actually really awesome. Or if I wanted to use standard form, I would just multiply my brackets out and then multiply it by 3 over 2, if the question asked you to find standard form. Okay, and then the last thing from A2 was finding the point of intersection between a quadratic and a linear function. So to find the intersection, the point of intersection, we just merge the two equations together. So if we're going to merge them, we just sub in this into f of x. So negative 4x minus 2 equals 2x squared plus 5x plus 8. Move everything to one side. So 2x squared, then we'll have plus 5x. We move the negative 4 over, it'll be plus 4, so that's plus 9. 8, and then we move the negative 2 over, it'll become plus 2. So that's plus 10. So we merge the equations, get everything on one side, and from this point, we're finding the point of intersection. So we want to solve for x, and the way that we do that is similar to finding roots. So we can factor or quadratic formula. So in this case, it's factorable. So I want it to multiply by 9. So I'm going to replace the middle term with 4x and 5x. Then I'm going to factor out a 2x from the first two terms. I'm going to factor out a 5. And then, since my brackets are the same, I'm going to factor them out. And then I have 2x plus 5 left over. Okay, so now that we factored it, it's equal to 0, so we can set each bracket equal to 0. And we're just solving for x. So we found x is negative 2 and x is negative 5 over 2. So we've got two values for x that we'll need to sub back into an equation. So when x equals negative 2, let's use our equation. Let's use the linear one. Seems easier. So we're going to sub negative 2 in. So negative 4 times negative 2 is 8. Minus 2, 6. So one POI is negative 2, 6. And then the other one we're going to sub in is negative 5 over 2. So y equals negative 4 times negative 5 over 2 minus 2. So if we multiply that out, we get 20 over 2 minus 2, which is 10 minus 2, which is 8. So that POI is negative 5 over 2, 8. So we have two answers, 2 points of intersection. So those are our POIs. And that's pretty much everything from A2.